Okay, so what's the point of this? Well, let me show you. Let me show you. When you were confronted with something like this, well, I don't have any tools that apply to this yet, but today I'm learning a formula that can help me. So, what's the idea? This is my original, this is my original integral here, and I'm going to replace it with this right-hand side. Now, the hope we have is that this integral on the right-hand side is going to be an improvement over the integral on the left-hand side. So we have to make some choices here. We have to choose u and dv so that that product u dv equals this thing here. So I'm going to choose u to be, well, I'm going to tell you 9 times out of 10, if there is a polynomial present, u will equal that polynomial. And dv is, well, whatever's left, e to the x dx in this case. Okay, so I have to check that u times dv does indeed equal this. Okay, so if it doesn't, then I'm in trouble. Okay, so now I do derivatives to find some other things. You'll notice that I'm going to need v over here, and I'm going to need du also. So du dx is 1. So du is just same as dx. And then to find v, you think of it as just doing an integral here. And you get v is equal to, well, just e to the x, right? When you do this. Okay, you may say, oh, hey, wait a second, man. There should be a plus c here. Okay, in this method, we just drop that. And we'll throw on the plus c at the very end. Okay, so let me start over. We had to choose a u, and we had to choose dv. Then we do a derivative to find du, and we do an antiderivative to find v. Okay, now we're ready to use our formula. So the formula says I'm going to get uv minus integral v du. So I just plug in everything I have. I get x e dx. So u times v is x e dx minus the integral of v e dx du, just dx. Okay, copy that. Now remember what I said above with the by parts formula. You are hoping that this integral is an improvement on this integral. In our case, we can see that this integral here is indeed much nicer than the original. Excuse me. We have removed our problem. The problem was this product here. Okay, it was x times e to the x. That's not easy to handle. So our problem's gone, and we are in fact done. The integral of e to the x is just e to the x, and that's that, plus c. All done. Okay, exercise. Let me see what I have for you. Um, Sorry. We'll do another example. Something more complicated. Um, so again, I'll choose, make some choices here. I'm going to go blue. It's a bit easier on the eyes. U is equal to, I'm going to go ln x here. dv will be whatever is left rather. So what is left over? 1 over root x dx. Okay, so du dx is equal to 1 over x. So du is equal to dx over x. So v is going to be the integral of x to the negative a half dx. So again, you put these integral signs here. Let's take a second to talk about this guy here. You know, integral of dv, that's the same thing as integral of 1 dv. And what is an antiderivative of 1? Well, that's just the variable. So it's just going to be a v, right? If I had a different, you know, if I had integral d whatever q, that would just be q plus c. Okay, so v is 2x to the 1/2. Okay. So what do I got? I got u times v, which I typically write with the polynomial in front, minus integral v du. v du. Minus, what do I get here? Get the 2 in front, integral x to the negative a half again. And then we get 2x 1/2, blah, 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 blah. Okay, so here I had to do power rule. Get this 2 again. So you get this 2 times the existing 2, giving you 4. So double check my answer. How did I do? Looks splendid.